just like any other problem that we have met in our life, or even in mathematics, even when we were young, we have always known that there is a different way to go around a certain problem, but still the same solution at the end. So similarly, here in transportation model or transportation problem, we also have what we call alternative optimal solution. The good thing about this is that um, the transportation problem will let us know if there is an alternative optimal solution. And this happens when one or more of the improvement indices or index are zero in the optimal solution. This means that it is possible to design alternative shipping routes with the same total shipping cost. Again, take note, if one or more of the improvement indices are zero, then that means there is an alternative optimal solution and it should give us the same total shipping cost still. So let's revisit the table that we had in the previous video. So this was the table that we had, and also this is the route. These are the improvement indices that we have calculated on the vacant squares. So for dy or dx route, we had an improvement index of 3. And for ay route, we have the 0. For by, we have the 2, and so on and so forth. So as you can see here, the AY route has a 0 improvement index, similar with the CZ route. These means that these two routes can be improvised, but it will give us still the same shipping costs. So let's check the AY route. So this was the AY route. We have the AY, AX, ZX, and CY. To be able to improvise these units that is being assigned to each cell, we will be checking the square that has the least number of units, or the negative square that has the least number of units. Since we have two squares right here that are negative, we have -2 and -4, and the least number of unit is 90, then we will be adding 90 to the squares that have positive sign, and we will be removing or subtracting 90 to the signs that have a negative sign. So for +4, we will be adding 90. For -2, or for the ax square, we will be deducting 90. So that will be 150 minus 90. And for the cx square, we will be adding 90 because it is positive sign. So 30 plus 90. And then for the negative, or for the cy square, we will be subtracting 90. So the new table will have to be 90. This will be 60. This will be 120. And this will become 0. Just like this one. So to check whether this new solution will give us the same shipping costs, then we will have to multiply 6 times 60, 130 times 6, 90 times 6, 90 times 4, 10 times 5, and 290 times 8 is still equal to $4,590. And take note that here in this table, we are now using the maximization unit cost. In the previous table, we were using the minimization cost, but it doesn't really matter because we are just changing the number of deliverables here in the said dealer. Okay, now we're done improvising the AY route. Now, there was a second route that gave us a 0 index, and that was the CZ route. So this was the original solution, and right now we are going to improvise the CZ route, and let's check if it would still give us the same shipping costs. So again, let's look at the negative symbol. So we have -4, and we also have negative 0. It should be negative 0 right here. And as you have seen in the negative squares, the least number of deliverables would be 90. So that means we will be adding 90 to the positive sign and removing 90 from the negative sign. So for the CZ square, we are going to add 90. For the CY square, we will be subtracting 90. For the dy square, we will be adding 90. And for the dz square, we will be removing or subtracting 90. So the new table will have to be 90. This will become 200. This will become 100. And this will become 0. Just like this. And still take note, guys, that these deliverables are still have still met the demand of each dealer and was able to exhaust still the capacity of each factory. So 150, 130, 30 plus 90 is total to 120, and 100 plus 200 is 300. So to check if it is still giving us the same shipping cost in total, then 6 times 150, 6 times 130, 6 times 30, 7 times 90, 5 times 100, and 8 times 200, still a total of $4,590. So in this case, in this particular problem, we can say that there are three optimal solutions for this particular example. This is as shown on the screen here. So whether you can follow this solution or the second solution or this third solution, it will still give us the same total profit in return whenever Factory X would deliver such deliverables to dealer A, to dealer B, and so on and so forth.